right, so my transformation is going to be whatever my vertex is. It's good that you can identify the vertex, whatever makes the absolute value equal to 0, your x-coordinate, and the y-coordinate number is the number on the outside. If there's no a term, which means the a term is assumed to be 1, I shouldn't say there's no a term. If 1's not written, it's assumed to be 1. What I mean by that is there a number in front of the absolute value. If there's no number there, it's assumed to be 1. We would argue that we're going left 2. Should be able to spell that correctly. Left 2 and up 3. My domain, I can put any number in for x. And to graph, I'm going to start by putting in the vertex, -2, 3. And now I'm going -3, -4. I'm counting down by 1s. I'm counting up by 1s. -1 plus 2 is 1. The absolute value of 1 is 1. 1 plus 3 is 4. If -1 gives me to 4, -3 should get me to 4. 0 plus 2 is 2. The absolute value of 2 is 2. 2 plus 3 is 5. So 0 gets me to 5. -4 gets me to 5. And these are what your dots should look like. And that's what the graph should look like. Based off the graph, my range, what represents my y's? The range is going to be y is greater than or equal to 3. Right? That entire graph does not go below the number 3. So the range is y is greater than or equal to 3. Find the vertex, axis of symmetry, and then where is it increasing and decreasing? Okay? -b over 2a represents vertex. So we're going -8 over 2 times 4. The double negative results in a positive 1. 4 times 1 squared minus 8 times 1 minus 4. 1 squared is 1. 4 minus 8 minus 4. Well, 4 minus 8 is -4 minus 4, that's a -12. No, it's not. Oops, sorry. -8. Excuse me. Who's about to yell at me at that, Sierra? Sorry, 4 minus 8 is -4 minus 4 is a -8. So my vertex is going to be 1 -8. Now when I go to graph it, 1 -8. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to use a 0 point. If I plug 0 in for x, I get -4. So 0, 1, 2, 3, 4. So it's 0, -4. And then it's symmetric, so my other point is my other point is 2, -4. So there is my graph. Okay? Now, the axis of symmetry always goes through the x-coordinate of the vertex. The axis of symmetry is simply x equals 1. Where is this increasing? Where is this decreasing? Well, think about this. If I started at -infinity on the x-axis and I went all the way down to 1, okay? I'm starting at -infinity on the x-axis. This graph keeps going down until my x is 1. That's decreasing. I'm decreasing from -infinity to 1, which means I'm increasing when x equals 1. As x goes to positive infinity, the graph goes to positive infinity. So it's increasing from 1 to infinity. Simply this. We change the sign of the number, x plus 2. The denominator goes in front of x, and we change the sign. That's it. And now we have to FOIL it. 3x squared minus x plus 6x minus 2. 3x squared plus 5x minus 2. That's the answer. Factor it. You don't need to solve for 0, you're just factoring it. I would argue the 3 is easier to work with here. There's no choices. I'm going to put 4x here and x here. because that gives me a 12x and a 1x. 12x and x can combine to be negative 13. Put a minus here and you put a minus here. And negative 1 times negative 3 gets me that 3 back. All this is basic factoring. The second one, we've gone over this ad nauseum of late. A minus b, a squared plus ab plus b squared. If a cubed is 64x cubed, then a equals 4x. If b cubed equals 125, then b equals 5, and we're just plugging the numbers in. 4x minus 5. The quantity a squared, so it's not 4x squared, it's 16x squared. 4x times 5, 20x, plus 25. And those are our factors. When we see the x to the fourth, essentially what that means is this. If this was x squared plus 12x plus 35, we would simply do x plus 7, x plus 5. And that would give me that middle term of 12x. But it's not x squared and x. It's x to the fourth and x squared. So x squared plus 7, x squared plus 5. That is the adjustment. X squared plus 7 equals 0. X squared equals a negative 7. And we take the square root of both sides, I root 7. And leave it as that. X squared plus 5 equals 0. X squared equals a negative 5. X equals plus or minus I root 5. Is this negative b plus or minus b squared minus 4ac over 2a? We should be well versed in this. My a is 5, my b is negative 4, and my c is 6. When they ask for the discriminant, they're just talking about this. That's the discriminant. So, negative 4 squared minus 4 times 5 times 6. 16 minus 120, which is negative 104. That's the discriminant. Since the discriminant is less than 0, two complex solutions. Remember, a discriminant that's greater than 0, two real solutions. If that discriminant is greater than 0 and a perfect square, two rational solutions. If it's equal to 0, a double root. If it's less than 0, it's complex. I'll be honest with you, I will accept basically two reals or two complex. You're probably not going to have to worry about the rationals on the test. Okay? It's real if the discriminant is bigger than 0. It's complex or imaginary. I'd rather us say complex if it's less than 0. Okay? So discriminant is greater than 0. Real solutions. Discriminant is less than 0 like we have here. Two complex solutions. Now, to answer the entire question, negative 4 plus or minus 16 minus 120 over 2 times 5. So that becomes 4 plus or minus the square root of negative 104 over 10. That becomes 4 plus or minus 4 goes into 104 26 times. So it'd be plus or minus 2i root 26 over 10. I think it's neatest to take the denominator and divide both terms. 4 over 10 is 2/5. Plus or minus the 2 over 10, the 2 cancels, I root 26 over 5. That is how I would write the answer.